This is the solution to random MathStat problem number 183. In this problem, we're given a random variable x having the continuous Pareto distribution. A new random variable, capital Y, is defined to be the log of 1 plus capital X, and we are asked to find the distribution for y. Let's start off by writing down the PDF for the Pareto distribution as given in this problem. This is one of those quote-unquote G-inverse problems. The random variable y is related to the random variable x through a function g. Let's write this function down, ignoring randomness for the moment. We need to invert this function, that is, we need to solve for x. G-inverse of y is e to the y minus 1. For our G-inverse formula, we will need the derivative of this function, which is e to the y. We're ready to go. The quote-unquote G-inverse formula says that the PDF for y is the PDF for x with G-inverse plugged in times the absolute value of G-inverse of y. Let's go ahead and write that Pareto PDF, substituting e to the y minus 1 in for every x, including the x in the indicator function. Don't forget to multiply by the absolute value of the derivative of G-inverse of y at the end. The problem asks us to name this distribution. In order to name this distribution, we need to simplify it so that we can hopefully recognize it. Let's start with the indicator. Note that e to the y minus 1 is between 0 and infinity. Adding a 1 all the way across, this implies that e to the y is between 1 and infinity. Taking the natural log all the way across, this implies that y is between 0 and infinity. So we can rewrite this indicator here as an indicator that just puts y between 0 and infinity. Take the time to convince yourself that overall, the PDF for y simplifies to gamma e to the minus gamma y times the indicator that puts y between 0 and infinity. We recognize this as the PDF for the exponential distribution with rate gamma. For part B, we're asked to find the expected value or mean for y. We already did most of the hard work here. Because y has an exponential distribution with rate gamma, we know that the mean for that distribution is 1 over gamma.